you're going to get at the end. If you want, you can still get a W. If you want to do that, you have until February 7th. Let me look it up. You have until February, I think. Oh, yeah, February 3rd, which is this day. So if you want to drop this class, you don't want the grade going on your Weaver State transcript, then you have to drop by this date. You'll get a W on your transcript. So if you're thinking about that, let me know. Come talk to me, or go talk to Tammy in the White House, and we can talk through your options. So technically the last day for Weaver State drop is the 24th of February, but Bonneville is trying to push us. If you're gonna drop, they want you to drop by that date so that they can find you a new class before midterms. So, okay, we are on chapter 8. We will talk about chapter 8 next week. Then we're going to be doing lab 10, which is another pretty long lab. And then we're going to review and then take the test for chapter 8. Woo! We have chapter 8, which is solutions. We're going to talk about solutions. Chapter 9 is acids and bases. Chapter 10 is the easiest chapter. It has the least amount of topics, and it's really just like memorizing some facts. It's nuclear chemistry. And then the last 3 chapters are relatively easy, as long as you put a little bit of time in. They are organic chemistry. So we're going to talk about naming organic chemistry, organic chemicals, and then looking at a few different variations of those. So this last chapter, the test didn't go super well for some of us. That also happened last year. That chapter 7 test has a lot of math. It's a lot of math, and it's a little bit tricky. So just remember, as we're going through, make sure that you're doing your homework. Make sure you do all of your homework. Make sure you get 100%. You're in control of that. That's something that in this class, if you get 100% on your homework, like, you are in charge of that. Like, if you do that for each of the chapters, that's part of your grade that you can control. So make sure you're doing that, and then also go back through Alex and make sure that you're really comfortable before the test with the topics. Chapter 8 also has a little bit of math. It has a little bit less math, but it still has a few problems with some math. And then chapter 9 also has some math, and then chapter 10 has like one problem that's sort of math, and then the rest of them don't have math. Okay. So that's kind of where we're headed. Questions on our schedule? Okay, so day 1 of chapter 8. So again, this is solutions. I think we're going to take 3 days for this, and these will be kind of medium length presentations. So hopefully you will have some time at the end of each class to work on your Alex homework. Okay, so part of this chapter is that there's different units. You need to make sure that you report the units that Alex asks for. Okay, so watch for that. We're going to talk about something called molarity. We're also going to calculate, so this is one type of concentration. We're also going to calculate mass concentration, and we'll talk about what that is. And then part of this is, I think we're going to do this next time. Part of Alex is you need to be able to model a solution. So when I put salt in water, what does that look like? Does it break apart into ions? Does it stay as a molecule? Like if I zoom in really close and look at the molecules, what does the solution look like? And then we also are going to do some dilution problems. And these dilution problems will also be part of chapter 9, the next chapter. So we'll learn it this chapter, but also use it next chapter. Okay. So the concentration of a solution is how much sample is dissolved in a liquid. You probably knew that already. So if it's concentrated, it has lots of sample. If it's dilute, it doesn't have very much sample. Those words sound familiar? You've heard those? Okay. So solutions are really important in chemistry because usually chemists mix solutions, and that is what they're making. That's what they're reacting. Okay, you've done that. You've had this bottle, and you put the drops together. You are using solution. So this is really important to know how to make a solution, how to dilute a solution, because chemists mainly use solution. There's a few kind of weird chemistry areas where you take like two solids and mix those together, and that is your chemical reaction. But usually, when we have some chemistry, it's in a solution. This is also like pretty relevant to our lives. Can you think of any solutions that you use? Can you think of anything that in your life that would be considered a solution, you think?
Saline solution.
Okay, for like contacts, okay. I think they also put that in your arm, like at the hospital. Wow, okay.
Water, technically, I guess.
So if there's something in water.
Oh, then, like the Neo stuff, I don't know what it is.
Oh, is it like a drink mix?
Yeah.
Okay. Okay, yeah.
Soup.
Would be a solution. Soup would be a solution. Yep.
Cereal.
Okay.
Yeah. Cereal.
So some of these are like suspension. So there's some technicalities with oops, I didn't realize that there's some technicalities there. But did everyone get the last slide with me? Okay. So this is the parts of the solution. So we have a solute. And I talked about these things in my regular chemistry class this week. They're not learning the same things that you are. So this is one of the things that we covered. And they said they had heard these words before. Have you heard these? Solute, solvent.
Yeah.
Okay, good. Do you remember where we learned them? Do you learn them in biology? Or like 6th grade, 8th grade? Or you just have always known them?
Just like
Standard
might have been
vocabulary?
like junior high.
Okay. 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 I mean, it's always better if it's a review and you don't have to relearn it. And usually, I think when I learn something the third time, then it starts sticking with me. So the solute is the thing that's dissolved. So I always think solute is like the salt. The solvent is like water. The water is considered the universal solvent. That's the thing that's doing the dissolving.
Oh my gosh.
What?
Sorry.
Oh.
Wait, isn't solute and solvent the same thing or no?
No, the solute is like if we took salt, or this is like cobalt chloride. You take the thing and you put it in water, and that makes a solution.
Okay.
Or like this would be like the solute would be like your drink mix, and the solvent would be like the water. And you mix them together and make your drink, your solution.
What is like distilled?
Distilled, is that your question? So distilled is there's some fancy equipment, and you basically just boil water, and if you boil water, only the water should evaporate. So you have pure water.
So it's just like pure water.
And then you condense it over here. So it should leave all the impurities over here. Let's see if we can find a picture. It's what? It's gross. Oh, because usually like this water, I mean you shouldn't drink this water either. But that water has like stuff dissolved in it. Yeah. Let's see if we can find the internet. Where does the internet go? Let's see what comes up.
And then like you're super duper tired, like after a practice, launched your water bubbles. That's all you have left. Is
Okay.
ice.
Here's like a chemistry grade one. So you like heat your thing. Oh, it's gonna be over here. So you heat your water up. It evaporates. It comes down here, and then there's this thing called a condenser, and you pipe in cold water, and that cold water cools down your evaporated water, and then you get out pure water. Or you can just go to the store where somebody has done this for you, and you can buy distilled water. So that's what distilled water is. Is that your question? Were you gonna?
I just want to know what distill it was.
So this is a distiller, like you distill. This is like the process of distillation. Yeah. Yep. And then, so this is like manual. If you're doing this in a lab, but then you can buy like fancier ones that stuff is like modern stuff. Yeah. Industrial grade. Yeah. Okay. Very good. So this is the equation that we use generally for concentration. So this is the most common one. A lot of things are, the lab procedures are in molarity, or they sell it in molar. So this is the most common for chemists, but different units, we can use lots of different units. And Alex will use lots of different units. So we use this big M. I think we talked about this one time. So this is, if this looks vaguely familiar, we talked about this once. So big M is molarity, so don't use big M for moles. They're different, okay? So make sure you keep those straight. And then molarity is the moles of the solute over the total liters of solution, or the total volume of the solution. And my equation, yeah, my equation got me this L should be under here. So let me see if I can fix that. There, yep, that L should be over there. I don't know why it's so hot. Is it hot in here? It's so
Something that's like humid.
Oh, really? Okay. Maybe another pipe broke. Yeah, it feels really hot in here. I turned the heat all the way down, but it's fine. So this is one of the things that Alex is going to ask you to use this equation. So sometimes it will give you the moles. Sometimes it will give you, so this is like a 3 variable equation. So as long as you have 2, you can find the other one. Usually you're just going to use moles, or number of moles over volume, to get the molarity. Okay, let's keep going. All right, here are some other units. So you might see these units in Alex. So we just have to watch for these and just make sure that you convert your initial values to the correct unit so that when you divide them, you get the right unit at the end. Okay, so watch for this. So moles per liter, I think, is the most common. But depending on your field, or depending on like even the company that you work for, they might have different standard units depending on what you're doing. So we also have like millimoles per milliliter. That's the same as moles per liter, but sometimes we just write like that. We can also use grams per liter, or grams per milliliter, or micromoles per liter, and millimoles per liter. So part of this chapter is going to be remembering how to do conversions. So if you've mastered this, you're really good at this from chapter like what, 1, and we practiced conversions. We did some conversions last time. If you're pretty good at conversions, then this will be easy. But if this is kind of rough, then make sure that you practice this conversion part. I think right now Alex assumes that you're pretty good at conversions, going from like moles to millimoles. And then Alex has that table. So if you can't remember, go back, look at that table that's there for you. Okay, so let's go ahead and look at an example of calculating a concentration. So it says, I have 0.288 moles of sodium hydroxide in 1,500 milliliters of solution. What is the concentration in millimoles per liter? So this is like an Alex problem because we have a requirement of the units that we're supposed to use. Oh, I'm going to try to use my pen today. I know it hasn't been working, but we'll try it today. So this is the units that I need to end up with. Okay, I need to end up with millimoles per liter. And my units that it asked me for are telling me how to do the problem. So if you can't remember the problem, I just need to find millimoles. I need to divide that by liters, and that's my answer. Okay. The tricky part here is that they don't give us either millimoles or liters. So this is moles, 0.288 moles. So how do we get this to, we need this to be in millimoles. So how do we do that? What are we gonna do?
Move the decimal to the right 3 times.
Okay, we're gonna move the decimal to the right 3 times. How do you decide to do that?
Wait,
Okay,
yeah, that's right. Because million means 1,000. I think so.
million means 1,000. Okay, so 1 milli is 1,000 moles. Would you agree with that then?
No.
No?
Think
So this prefix is 1,000. So 1 millimole. Oh, and I need to put moles in there. 1 millimole is 1,000 moles.
No.
No.
Toby. No.
Oh, it might.
Is that?
Would it be 1,000 millimoles in 1 mole?
Yes.
Yeah,
you're right. Okay.
that would be the other way around. That makes more sense.
Okay, good.
Trevor was just laughing at us the whole time.
Oh,
Stop laughing at me.
where's my
I'm
tools?
sorry, Alden. I'm sorry.
So let's get out our eraser.
Your face was just like.
Where's the Okay, so you're saying 1,000 milli. Oh. Oh, now the pen's not gonna work. When the person comes to watch me, the pen works. Okay, do you agree with that?
Yeah, like that. Yeah.
Okay, 1,000 millimoles is 1 mole.
Yeah, that makes more sense.
Okay, so here's my decimal. Here's my decimal. We have moles. We need to get to millimoles. So you're saying you need to move the decimal.
Yeah.
Okay. So 0.288 moles is 288. And I'm going to write millimoles instead of whatever that was. Okay, so now we have millimoles. That's our top number. Now we have this many milliliters. So now we have milli. We're going to liters. We need to move the decimal. One, two, three to the left. So what would our number be? Okay, 1.5. Okay. I'm going to message the tech person. It works when he is watching.
Millimoles per liter.
Okay, good. So then what's our next step?
So we divide those, so it's going to be 288 millimoles divided by 1.5.
Good. Okay, and then what did you get? Yeah.
192 millimoles per liter.
All right, let me try to write it down again. Okay, tell me the number again.
Oh, 192.
192, and that's millimoles per liter. Okay, so this type of problem, we also have to watch out for sig figs. So is this the right number of sig figs?
Yeah.
Yes, because we have 3 sig figs and 4 sig figs. Okay, he's going to kind of help us. Okay. Well, if I just click enough, it will change. right, next question. Do you want to see if you can do this one?
Yeah.
Okay, so look for the units. That's all of these units are going to tell you how to do the problem. Grams per liter. So look for grams per liters.
Do we need to find the moles per gram or just the molar mass?
This one's
Grams per liter.
a mass volume or a mass concentration. This one's called mass concentration because we're doing grams per liter. So no, not this one, no. Hello.
All right.
Good. So when they're watching, it doesn't work.
Okay.
So they're doing this one, but what we're trying to do is draw on the board.
Does it seem like it's just doing like a mouse?
Yeah.
The gestures on it.
So I have to.
Okay, so it
So
worked. It worked.
it was
for the
working.
portion,
Yeah,
right?
yeah. And then I turned the eraser on. I don't know if that came off. I turned the eraser on and then I turned it off. I don't know. Okay. I don't know. Do I just have to?
I wonder if you'd have to switch. So go back to the eraser and see if it. Okay. So
And then I went back to that.
okay.
Okay, now it's working. Yeah. So maybe if it's doing that, I just need to click on that and like make sure it knows that I want this.
Yeah. Let's see. So there's no other function of the laser pointer that would give us any other function, huh?
Yeah.
Okay. So maybe it was just having a software problem. Because what we're doing, we're using the software in PowerPoint right now, right?
Yeah.
Okay.
So maybe just make sure, just if it's doing that, just pull this up again and
Yeah. I'm wondering
go
if
back in.
or if it's like
It
a
like
PowerPoint
somehow
issue. Yeah.
lost.
It kind of feels like a PowerPoint issue. I don't know all the things that are going on behind the scenes, but
Oh, I also
it
know.
does feel like a PowerPoint problem.
Okay.
Yeah, whatever the options. Yeah. Because even if I use my finger down, it'll work.
Oh yeah, you're showing me that. Arrow option.
Maybe I toggled it off, and so now.
Oh.
Okay, so I think that's
Oh.
so you can switch between gestures. And pen. There we go.
Oh.
So I guess if you just tap on that.
So now the
I
pen's
guess
off.
it's just a toggle.
Now the pen's on.
Okay.
Okay.
So when it's clear like that, I guess.
So the
that's
pen's
it.
off. Okay. Actually, that's smart.
So and that's good for like when you want to like go to your next
Yeah,
slide,
okay.
right?
Oh yeah, that's nice.
And then we'll turn it to pen to right.
Okay. Oh. Okay, that's helpful.
Okay, yeah, that's.
Thank you.
I learned something new, so
Okay,
thank you.
me too. All right, thank you.
Cool.
And hopefully all of you, now you can, if your teachers are, or if I forget, you can. Okay,
Okay, cool.
thank you.
Yeah.
Okay, so what did you, walk us through, how do you do this one?
Convert milliliters to liters.
Okay, what did you get?
2.25.
And that's liters, okay?
Yep.
And then what?
And then you're going to do that equation.
Okay,
So grams per liter, it's going to be 17.2 grams
okay,
divided by 2.25.
okay. Oh, and I have liters already. And what did you get?
7.64 grams.
Oh, 7.164, 614.
Just 6.
Oops. Let's try the grams per liter. Okay, and I agree with your sig figs. You have 3. The lowest one has 3, so that seems reasonable. Okay, Do you want to try another one? This one has micromoles. Okay, try this one. See if you can remember micromoles. So the micro, when I see micro, that makes me nervous. So see if you can do that one. You might have to look in Alex. No, we'll do it together.
Oh, yeah. I thought it was I didn't look at all this. What you get done? 3. How would you get the micromoles to millimoles is what you did? What would you do with that? Decimal 3 times. So micros 6. So 3 times. Decimal. Yeah, I think you're correct. Is 3. So we should have the decimal. I think that's right. Yeah. Were you the only one talking your own? Yep. Really? That was great. It sucks. Well, why is it a charter talk a little bit, I guess? Yeah. You usually were the quiet one in the other class. The last semester one.
That was
wild. With Cooper stuff and yeah.
All right, how do we do? Do we get it?
I
Are
think
you
so.
ready? Okay.
Yeah, I think we got it.
Okay, how do we do this one?
So since it's micro, you move the decimal. We're going from micro to milli.
Okay, micro to milli.
So it's going to be moving the decimal point 3 times. To the right.
To the right.
Yeah.
And so that is this many milli?
Yeah.
Okay, so which one is a smaller measurement? Is micro molar smaller or millimolar?
Micro.
Okay, so this one's bigger.
Because I thought like, to get from micro to like a regular mole, you move it 6 times.
You're
So
right.
if we're going
But
to
I think
milli,
you go,
you got 3 times.
you're gonna go the other way.
The other way.
Because millimole is a bigger unit. So we need a smaller number. This is a smaller number. So we need to go the other way. Does that make sense? But you're right, we need to go 3. 1, 2, 3.
So we 0, 1, 0, 0, 0, 3.
So that's millimoles. And then, so now we have millimoles. This is telling us millimoles divided by liters. So how many liters is this?
5.
So that one, hopefully the milliliters to liters is pretty straightforward. Okay, then we divide by 5 liters. And then this will give us millimoles per liter. And what did you get for this?
0.0003.
Okay, and then how many sig figs should we put on this?
3.
We should put 3. So this has 1. So we're gonna put 2 zeros after it.
That's so silly.
It is. That's true. Okay, questions? Okay. So make sure you practice these ones. There are some shortcuts, like there's some where like, I can't remember them right now, but if you have like moles divided by milliliters, and that already gives you millimoles. So there's some shortcuts. So as you're working, if you notice there's some shortcuts, use the shortcuts. Okay, there are some algebra problems also. Was this one on Alex? Let's do one of these. So we know that if we have, I think this is. So if we have this equation, molarity is moles per liter. And it's asking me how many moles. This is just an algebra problem, okay? So if we have this, we have 1 molar. We don't know how many moles, so I'm gonna write an X. We do know how many liters. It tells us 500 milliliters, which is 0.5 liters.
Yep.
So then if we multiply across, so we're just doing an algebra problem. We have X divided by 0.5. I'm going to multiply by both sides by 0.5.
Oh no.
Turn the pen. The pen just turned off, I guess. Because that's what I hate. So this cancels, and we end up with 0.5 molar, or moles, excuse me, moles. We're looking for moles. Oh, why did the pen turn off? I don't know. So this many moles. Okay, does that make sense? We can use that. If we have 2 of these, we can find the third one. Just an algebra problem. Solve for X.
Okay, wait. So do we move the liters over to
Oh.
the left?
We can also, yes. So that's liters. So this is molarity, which is, we can replace this with moles per liter.
Okay.
Liters cancels. And our units should work out. Yes, good. Yeah, units should always work out. Okay. I think we're going to skip the rest of these. So this one's just an algebra problem. Write what you know, solve for what you don't know. Convert milliliters to liters.
I'm confused with this. So it's not liters. That's going to be molarity.
Okay. All right, this is the last part that we're going to talk about. Yeah. I don't want to fix it right now.
Really?
Well, let me keep this. Yeah, this is our last part. Where is this? So this equation is the dilution equation. So usually what happens is chemists buy something, it's concentrated, and we need to dilute it. So it's like you buy concentrated orange juice, you want to make a liter of orange juice, you put what you need, you dilute it to the correct volume. So we have N1 times V1 equals N2 times V2. So this is like my initial volume times my initial concentration or molarity equals my second concentration times my second volume. What I end up with. So this is a really common equation that we use. This is something that I've used this year to prepare some of our labs.
This is like that one law, right? Oils or something.
Oh yeah,
Yeah,
this is
yeah.
yes, just like that. Proportional. Yes. Good connection. And then over here we have this beautiful dilution series where it starts very concentrated, and as we dilute that, we can get less concentrated. So we could use this equation to calculate the dilutions that we need. So here is the first story problem. A chemist needs to dilute concentrated sulfuric acid to 1 molar. The chemist needs 100 milliliters of the solution. Concentrated sulfuric acid is 18 molar. What volume of concentrated sulfuric acid should the chemist measure? So this is really common with acids because acids come as really concentrated. So sulfuric acid is 18 molar, hydrochloric acid comes as 12 molar. There's one that comes as 36 molar, but I can't remember. Nitric acid, I think, comes as 36 molar. So we need to figure out which goes with which ones. So it says the chemist needs something in 1 molar.
So that would be M2.
Good. Oh, we switched colors. M2 is 1 molar. That's what we want to end up with. Okay. The chemist needs 100 milliliters.
That's gonna be the
We need to end up with
The
that.
volume of it.
Volume.
So volume
Why
2.
does this keep turning off?
So that should be volume 2, and then, yeah.
Do you see
So we're
that?
trying to find volume 1.
Okay. Yes. Volume 2 is 100. And this one we don't have to convert because the units will work out. And then we have M1, which is 18.
I love the volume.
Well, we're looking for V1. Okay. I'm just going to write V1 as V1. So then we just, if this is an algebra problem, we have 4 variables. We have 3 unknowns so that we can solve for the 4th unknown, just like in math. Hopefully you've done this in math. So we have 18 molar is M1 times V1. We don't know V1. That's our variable that we're solving for. And then we have 1 molar is what we want to end up with. And we need 100 milliliters of that. So this is going to tell me how much of this concentrated stuff I should measure out. And then I'm going to dilute this volume 1 to 100 milliliters. That will give me my 1 molar. So how am I going to solve for V1?
divide 18.
Good, divide by 18.
Since it's 1 times 100, it's just gonna be 100 divided by 18.
Good, and then if you're watching the units, the big M cancels out, and we get just milliliters. So this problem we don't have to convert to liters. All right, what did you guys type in? I've also interrupted the units.
5, okay. I don't know, 6, 5.6.
Okay, yeah, and this one has 1, so we'll go with 5.6. That seems better. Okay, does that make sense? All right, let's look at this pattern. So this is talking about the ending solution. So if you can connect 2 of the numbers, you're going to multiply those 2 numbers together and divide by the other number. So multiply by these 2 because they're talking about the same solution, divide by the odd one out. That's the pattern. So you can set it up every time, or if you see the pattern. So these go together, find the ones that are talking about the same solution, multiply, and then the odd one out, you're going to divide by that one.
Oh, okay.
Okay, do you want to try another one together? Okay, do you want to try one, or do you want to do it together? Do you want to do this? Try it. Okay, you guys try it.
Does it matter what unit the moles is in?
So as long as they match, as long as these are both in the same units, and these are both in the same units, then it doesn't matter. Because they should cancel out. Are you doing one on Alex?
Then how would I set this up?
Oh, moles per liter is molar.
Oh, wait, hold on. Why do we have?
And this one is millimolar.
So I have to change one.
Yeah, so you would,
3
yeah,
times.
do, if you move the decimal 1, 2, 3, this is 734.
0.5 m, 0.1 m, 0.5 m.
Yeah, good.
So last 0.5 is the same as the first 0.
Okay,
Thank you.
that confused me for no reason.
100.
Oh my god, that came out of the number. I was figuring it out on my own.
And then you know if you're wrong.
You got 100?
Yep.
I got 1,000.
You put in an extra 0, I guess.
Okay. So 0.1
Yeah,
times 500
Oh,
equals 50.
wait, just kidding.
Right. And then divided.
Stop talking. Stop talking. You figured out on my own.
So,
Okay, I got it.
Shut up.
Okay, I can't tell if you guys are working. It looks like you're done.
I'm done.
Okay, what did you get?
100
100, and what's your unit? What did you get for the unit?
milliliters
100 milliliters, and what's that telling you? 100 milliliters?
are needed to get 0.5 molarity of
Magnesium.
magnesium dichloride.
Okay, and yep, magnesium chloride. This one's ionic, so no, say that. Good. Okay, and did we get that? Did you also get that? Okay, what's the shortcut here?
So I have.
Okay, so look like this. Like the first one,
So,
first one,
This is talking about the same solution as this one. Currently, we have 0.1 molar with at 500 milliliters. So that's talking about the same solution. So if it's talking about the same solution, we're going to multiply them and divide by this thing that's odd, the odd one out. That's a different solution, a future solution. Okay, so that's a shortcut. All right, do you feel okay about this? We have one more practice, or do you want to just do Alex?
Alex,
Okay.
unless, yeah.
All right, we've got half an hour left. So go through Alex. I'm gonna hand you out this solubility chart because this isn't Alex, but we're gonna talk about it next time. But if you come across this question, you're just using this, and it's really annoying to do the Alex chart. This is just really hard to see in Alex.
Do I have to write that whole thing on
No.
my card?
If you don't write on this, you can use this on the test.
Okay.
There's also, this is exact thing, I got this from the Alex data. Does that make sense? So I'm just giving you the thing that's already given to you.
Okay.
So as long as you don't write on that, you can use it on the test. If you lose it, then you'll leave the Alex one. It's a pain, but you can do it.
Oh, crap. Oh, yeah, I need to do that as well.
No, I'll start up. Did you already do your model?